Welcome back. This is the last video of our session about evaluation of binary classification models. And here we will just go over all the materials we covered this week. And yeah, so here we talked about metrics. So metric is a single number that describes the performance of a model. So accuracy, for example, or precision, recall, these are all examples of metrics. So area under the ROC curve is also a metric. So we talk about this kind of metrics. And so let's just quickly go over all the things we covered. So yeah, we used the same data set as we used in the previous week. We talked about the problem of churn prediction. So we used the model from the previous week. And first we looked at the accuracy metric, and then we evaluated the accuracy of our model across different thresholds to understand which one is actually the best one. And we saw that 0.5 is actually the best one. This turned out to be the default one. And another interesting thing we noticed here was this model, that when we evaluate at 1.0 threshold, we have a dummy model that treats everyone as non-churning. So it just says that no one is going to churn, and it predicts false for everyone. So this is quite a stupid model, not very useful for us, but it was surprising that the difference between this model, the dummy one, and the difference between our model was actually not that big, right? It was 7%, which means that accuracy is not the best model for this kind of problems. And with these kind of problems here, we actually have a class imbalance problem. So we have 72% of our customers in the data set are actually non-churning. So that's why a model that predicts everyone as non-churning has a decent accuracy. And then we talked about confusion table, which is a way to describe different types of errors and correct decisions and arrange them visually in a table. So we talked about true positive and true negative, which are correct decisions. And we talked about false positive and false negative, which are incorrect decisions. And yeah, so we put them together into a matrix that looks like that. And then we talked about precision and recall metrics. So precision is the fraction of positive predictions that are correct. So among all the customers for who we predict churn, how many of these decisions were correct? And the precision of our model is 76%. And another thing we talked about was recall. This is a fraction of correctly identified positive examples, so fraction of churning users who we managed to correctly identify. And we see that for our model, recall is not that good. And I think what we didn't talk in the videos, but what we should have talked is that precision and recall for dummy model is quite bad. So I think this is what you can do in the explore more session. Let me just quickly add this. Okay, so let's go back. So we talked about precision and recall, and then we talked about ROC curves. And the ROC curve is a way to evaluate the performance of a model across many different thresholds. So we look at things like true positive rate and false positive rate, and we plot true positive rate against false positive rate. So this curve shows us how well our model behaves across different thresholds. There is this ideal spot, and we want our model to be as close to the ideal spot as possible and as far from the random baseline as possible. To actually quantify that, how close we are to the ideal spot, we can compute the area under this ROC curve, so which is often abbreviated as AUC, area under the curve. And this is something we also talked in lesson 6. And one of the interesting things about AUC is its interpretation. So it tells us what is the probability that a randomly selected positive example has a higher score than a randomly selected negative example. So in essence, it tells us how well our model separates positive and negative classes. So if all the positive classes have higher scores than negative, then we have perfect separation. If there is some overlap like we have here, then this separation is not perfect. Yeah, basically it also helps us quantify. So in addition to just telling us how far or how close it is to the ideal spot here, we can also have this nice interpretation And then finally, in lesson 7, we talked about parameter tuning and selecting the best parameter for our model. So logistic regression has a parameter C that we didn't talk about much. So we can also tune our model to select the best one. In the previous sections, in section 2 and section 3, we just hold out a validation data set and use it for evaluating the model and finding the best parameter. But instead of that, we can split our full training data set into multiple folds. So it can be, for example, 3 folds or 4 folds or 10 folds. And then we use 1 fold for validating the model and the rest are used for training. So let's say if we have 10 folds, we use 9 for training the model and we use the remaining 1 for validating, and we do this 10 times. And at the end, we have 10 scores, and we can use these scores to understand what is our average score across all the folds, and we can also understand the spread between different folds. So how different the behavior of our model is across different folds. We saw that the default value of C of 1 is reasonably good. So it's as good as other values around it. So we just went with this and we used C equals to 1 as our final value, and we trained our final model using the full trained data set. We evaluated it on the test data set, and we saw that the performance on the test data set was slightly better, but it was nothing surprising for us. And we concluded that the model is good enough and it should work well with unseen data. And that's it. So then we have explore more section, which I just modified a little bit. So if you want to learn more about this topic, you can check this out. Next week, in the next session, we will cover model deployment. So we will take the model that we just trained here in this cell 131. We will take this and we will save it, and we will put it in a web service, and we will see how it can be used. So see you soon.